Welcome to True Projects. In this video, we will explain about scalable detection of crowd motion patterns. Introduction. Crowd movement analysis is critical for understanding and forecasting the behavior of huge group of individuals. When analyzing crowds, the long-term macro-level motions of the crowd as a whole are often more interesting than micro-level short-term movements of individuals. As a result, a high-level depiction of these motions is desirable. We offer a scalable technique for detecting crowd motion patterns, that is, geographical areas representing the relevant motions inside crowds in this project. We offer a rapid, scalable and low-cost approach for tracking crowd movements based on proximity graphs. Here we use three-stage pipeline to analyze crowd movements. First one is depict each person behavior at each point in time as low-dimensional data point. Next one is cluster these data points based on spatial relations. Third one is concatenate these clusters based on temporal relations. Objective. The project's goal is to develop a scalable method for detecting crowd motion patterns using sensor data. The goal is to discover population movement tendencies in densely populated locations, which will aid the avoidance of anomalous activity and traffic management. Main goals are to handle data efficiently and separate relevant sub-trajectories using tracklets, discover shared behaviors using spatial clustering, and integrate smaller patterns coherently using temporal clustering. The project illustrates practical application using simulated and storm information, emphasizing the potential for insights into crowd behavior and urban development solutions. These are the requirements needed for execution of the project. In hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, Python IDE ELF 3.7 version is needed. These are the modules used in the methodology. First one is tracklet extraction. To extract sub-trajectories or tracklets, algorithm for trajectory segmentation and pattern recognition could be employed. Algorithms like dynamic time wrapping, which is DTW, Frechet distance, or even simple heuristic methods may be used to identify relevant patterns within trajectories. In this module from graph data, we will extract only sub-trajectory, which is location data, from full data by applying proximity graph. Proximity graph finds patterns such as turn left or taking elevator from complete data. Next one is spatial cluster. Spatial clustering involves grouping similar behavior or patterns together. Algorithms like k-means clustering, db-scan clustering, or hierarchical clustering might be used to cluster tracklets based on location data. In this module, extractlet tracklet will be clustered to find similar behavior or patterns, and these similar patterns will put inside same cluster. In spatial clustering, only location data will be clustered, and if same person doing same activity again and again, then his clustering behavior will be same and same data will be recorded. Next one is temporal clustering. Temporal clustering focuses on merging smaller clusters into coherent motion patterns. Algorithms like agglomerative hierarchical clustering or spectral clustering might be applied to identify sequential patterns and combine them. Large motion patterns could get splitted into multiple smaller motion clusters to combat this fight. The final stage of the pipeline concatenates the multiple smaller clusters to create larger patterns based on temporal coherence between clusters. Clusters that are frequently visited in sequence should belong to the same pattern and they are combined. For execution of the project, first open the code folder. This is the code folder of the project, and this is the dataset folder, and this is the dataset. These are the complete dataset points. And this is the main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this we can interact with the program, and this is created by using Tkinter library in the Python. So first click on the button Upload Trajectory Motion Dataset to upload the data. Here I will select the data and click on Open. Here dataset is uploaded. Now click on the button Tracklet Extraction to extract tracklet from dataset. Here, total trajectories in the dataset are 608 and total number of trajectories are 18,951 and the generated total tracklets are 7,974, which contains the patterns such as turning left, right or tackling elevator. Now we have tracklet subtrajectory information. Now click on spatial temporal clustering button to cluster tracklet, and then application will detect movement and display all those detected movements in final cluster. Here, in the first graph, it contains total trajectories. In second graph, it contains subtrajectory and tracklets. In the third graph, it contains density points, and in fourth graph, it is displayed that centers for clusters. Now, in the fifth graph, it is showing dendrogram, and then it will generate final last graph. Here, figure reveals that dataset contains a clear dominant curvature. Hurricanes originate from the northeast, move towards the southwest and terminate either in the west or in the southeast. Close this graph. Close this UI. Conclusion. Using sensor data, the project effectively demonstrates a scalable for identifying and interpreting crowd motion patterns. The project effectively discovers important patterns within big baskets using tracklet extraction, geographical clustering and temporal clustering algorithms. Simplifying data analysis, the use of these techniques on synthetic and hurricane-inspired datasets demonstrate their efficiency in capturing crowd behavior. The project emphasizes the significance of scalable data processing in crowd analysis and suggests applications in crowd control and urban planning. Overall, the project's approach helps us better understand crowd dynamics and their implications in diverse settings.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.